Hello folks. So in this video I wanted to actually talk about inodes and file systems. So this is just going to be a what do you say basics thing. So I just started learning about inodes and file systems again because I learned this back in the era of 2013 to 2017 during my college when I was doing my bachelor's degree, so UG undergraduation. Um, so, I mean, the company that I'm currently in, I had a question that was asked to me about, disk space usage and all. So, just a minute. So, for example, the question that was asked to me was, let's say you get an error saying that disk space is full. What do you do, right? So I told them that I would check what is using up the space, where is the space being used up by checking with the df command, which is short for disk free, right? And you can actually check it out even in Darwin or like macOS, display free disk space, right? And then you also can check out disk usage, but it doesn't tell you how much is free or how much is the total. It will tell you how much is being used, right? So df and du are the tools for you, right? Just a minute. Very great. I know the commands. So just say bash, and this is disk free, and this is disk usage, right? So you can actually do something like df-h, right? Or df-capital H, right? Both have some meanings. I think it's basically some form of human readable. Hyphen H and hyphen capital H. Small h is human readable, same as hyphen H, capital H, but based on the powers of 1000, right? Like 1 kilobyte is 1000 bytes, and things like that, instead of 1024. Um, cool. So here is based on 1024, the hyphen small h. So just a minute, I wanted to check this out. What was this? Gigabyte. Okay. I don't use that gigabyte or gigabyte and all that. And then the default is always okay. Cool. So you basically just use these commands to find out if the disk is free, how much of the disk is free, how much is used, what is the capacity, like the total, and what is the free, right? So, for example, over here you can actually see that for me 7% is like used, as you can see over here. 1 minute. The total is 494, used is 11 GB, available is 166, right? And if I look at hyphen small h, it's something close. In percentage, at least, it's mostly close. So I think basically here 154 GB out of 460 GB. I think capacity. I don't know why it says capacity over here. Ideally, it should show used percentage and all that. We'll come to this. What this is? I used, I free, um, I used percentage. So basically, I was told that when you check these commands, you notice that there is still some disk space free. Right? So there is still some free disk space, but it says disk space is like full, no space left on device. So the issue was around inodes. So I was told that just a minute. So I was told that like I was asked if I know about inodes, and I said no, I don't know. Interesting. I know. No, I don't know. So basically, inodes you check it by doing df-i, right? So what are inodes basically? So inodes are like they're actually called a data structure. In the context of what? In the context of file systems. So this can be any file system, but usually this is specific to actually Unix file systems. So Unix like file systems. So where you have Unix like kernels, operating systems, for example, Linux, Unix, Darwin. and they have file systems like ext4 and all that. So there you have this concept of inodes. Let me show you what that looks like. So inodes, if you just simply Google, you'll notice that it says it's short. It's a short form. It's short for index node. I is short for index. So inode is basically index node. It's a fundamental data structure in Unix-like file systems. So if you've learned like some computer fundamentals and basics, you will know that file systems is a popular and very important concept you learn, as part of any operating system class. So I learned this long back, and we even implemented some dummy file system and all that, like just to show how a file system works, right? But I didn't try out actual file systems, and I didn't try out stuff around inodes. At least I don't remember trying it out. So I thought now is the time. Why not? I was thinking I want to learn something every day, bite-sized. So I thought I'll learn about inodes, right? So inode is not just specific to say Linux. You can also find it on Unix. You can also find it on, I mean, anywhere where it's like a Unix-like system. So Unix, Linux, even Darwin, basically in macOS. So these are data structures that are in the context that are present in the context of file systems. So these are data structures in these file systems, and that stores metadata, which means data about files. So or a directory, like in metadata about a file. Say there is one file and you need some metadata around it. For example, the metadata can be something like size of the file, the permissions, access permissions, the owner, and any timestamps like created it, updated it, and all that. But this metadata does not have the file name, interestingly. And of course, it's metadata, it's not the data itself, so it does not have the file content. So every file or directory gets a unique inode number. But remember that inodes is a concept only in some file systems. It's not in all file systems, right? So, for example, one file system that has the concept of inode is ext4. It's a file system. So ext4, if you look at it, ext4 file system. Oh, sorry, I wrote it as ex4, not ext4. So fourth extended file system. So I think ext is short for extended, and the fourth version is most widely used stable journaling file system for Linux, right? Serving as a successor to ext3, and there are ext2 also, I think. So offering major improvements like larger file volume sizes and all that. So there are a lot of nuances. I still haven't read all of it. It has some information like something about fragmentation. I think that's about how the data is kept in the hardware, the storage, say hard disk drive or solid state drive, whatever it is. So and how things work and all that. So we'll get to this later. For now, we'll just get into the idea of what is an inode and in which file systems does it come up and what does it mean. So inodes, as you can see, the basic thing is that it is used to store metadata about a file or a directory, and it comes up in the context of a file system only. And file system has this data structure called inode, and not all file systems, only specifics, like for example ext4. So the characteristics, yeah, every inode has like a unique identifier, like it has a unique number. So, and basically every inode is identified by a unique number, so called the inode number. So let me try to show you that. So each file or directory has one inode identified by a unique number within its file system, right? So I guess if you have multiple file systems of the same type, for example, ext4, there are two ext4 file systems in your machine, each mounted at different directories, and they are both separate and different, as in different in the different instances of the same type of file system, which is ext4. Then each will have some unique number, I guess. So if there is one in one of them, there can be one same unique number, but within that namespace, within that file system, I believe it's a unique number. This is something to check out. We will see if we can try this out, check this out. And then, yeah, the name is separate from the content. file name is a separate entry in a directory linking to the inode. The inode points to the data blocks. So inode has information like where are the data blocks for a file. The data blocks are pointers or addresses. Basically, data blocks are the blocks where your data is actually there, and inode points to it using a pointer, address pointer of sorts. So it stores where the data is being stored in the hardware. Like, let's say it's a disk. In the case of physical storage, there are other file systems like network file systems, distributed file systems. We'll not get into that. I'm yet to dig into that. So we'll just assume it's a hard disk, not even solid state drive. Hard disk. Where is the data present in that hard disk? Like, I need to learn more about how that happens, like how you address each part of the hard disk and all, and how things work there and how the file system works. But this is like the high level idea that there are data blocks, like each file content is cut into blocks, and the inode that is responsible for a file. Uh, for directory is different. For a file, it will point to the data blocks uh, where the different blocks of the file content are stored in the hard disk. So the data, so this is what I was talking about, data location. So contains pointers to the physical data blocks on the disk where the file's content resides. So it's file system specific, are unique to a single file system. So yeah, it's clear over here itself. So two different file systems can have files with the same inode number, right? So why they matter? Resource management file system has a limited number of inodes. Like not all file systems have inodes concept, but let's say ext4 has inodes concept. They have a limited number of inodes. So creating, let's say, lot of small files, millions of small files, like tiny files that are like 0 KB or 1 KB, whatever, can exhaust inodes. So every file needs an inode to tell the metadata, the size, where the data is present in the disk, right? So and access permissions and all. And let's say there are some 100 inodes, for example, just for an example. And if you create 100 files, even if your disk has enough space to store more files than those 100 files, it will still say no, this space is not available. Like some errors will come up, right? Efficiency integrity, will come back to this later. I still haven't read more about it. So how do you understand, like how do you see the inodes? You can see them by using the df-i command or ls-i command, right? So in Linux or Unix, you can use this. So let me show you. Let's say this is my directory. So as you can see here, this is actually a directory called Linux. Interestingly, I'm on Darwin, by the way. It's not a Linux machine, so it's a Darwin machine, macOS. So if you simply do ls-al, or ls-l also works. A will show you even the hidden directory.